Hello everyone, welcome back to my channel. Hope you guys are doing great. Here where I am at this point is like 30 degrees Celsius. In here is super hot, and but yeah, it is what it is. Summer is approaching here, and so yeah, it seems that this kind of weather is going to last for a few months up until the end of the summer. But anyway, so in this video, I'm going to give you an overview of an event that the CFA Institute put together earlier this week on the use of unstructured data and artificial intelligence in investments. And so the event was about 1 hour long, but the focus here was, or rather will be, on the key takeaways for everyone who is interested in these topics, basically. And so there were two guests at this sort of presentation, or this meeting. And so the first of the two guests was Mr. Andy Moniz, who is also a CFA charter holder and works as a director of responsible investing at Acadian Asset Management in London. And so in his presentation, Andy describes the evolution of natural language processing techniques over the years, all the way since, I believe, the 1948, 1950s, all the way up until now. And so he described basically these techniques, and as well as their investment applications. In particular, in portfolio construction, stewardship of the assets, engagement with the companies, as well, to make sure that the companies are held accountable for their commitments, especially in terms of ESG. And so the purpose, basically, of generative natural language processing, or as they usually call it, NLP, is basically to predict from a sequence of words what the next words will be. And attempts to do that have been going on, as I said, since basically the 1950s, when the first technique, the so-called bag of words, was introduced. However, the bag of words technique only began to get more attention, I believe, from 2007 onwards, basically because the technology that began to be used at that time was granted a little bit more facilitation about using this technique. And so basically in a bag of words, the frequency of the words is what really matters to predict what the next words will be. And so their sequence, for example, is not really important. But the problems are with this approach, with the bag of words, is first, there may be many words in a given text, and second, there usually are many words which do not have any significant meaning, such as, for example, the so-called stop words such as de, or of, or is. So these words are likely to appear the most often in a particular text, but they are not really significant. They don't have any meaning for any algorithm to understand what's the content of the text. And so this is one of probably the biggest shortfall or pitfall of the bag of words. And another problem of the bag of words is that it does not try to understand the meaning of the text itself. And so by relying only on the frequency of the words, the perceived meaning of the text can be completely different from its actual meaning, especially because, mainly because of the words that are in there. And so this is a very basic technique by and large, and so that's why nowadays it's not much used anymore. And so the second technique that Mr. Moniz spoke about is the Bayesian modeling, which began to be used in the field of bioinformatics to do, I believe, DNA. He mentioned DNA research. And it is also the first technique to use probabilities in its approach. And so what it does is that basically it populates a given text, assuming that each of the topics to be discussed in there has a specific probability. And so the words related to a more likely topic will appear in the text more often. And the words related to a less likely topic will show up less often, as expected. And so it can also be used as well to reverse engineer the topic of a text, simply by assigning the words in it to a particular set of topics. And by doing so, we get an overall understanding of the flavor of the topics being discussed in that particular text. Of course, this is a little bit more sophisticated than the bag of words, but nonetheless, it's still pretty basic, I would say. And so the third technique is the semantic web, which relies basically on searching the internet to acquire human expertise on a given field. Because, of course, as you can imagine, the internet has already quite a lot of insights that can be used by an algorithm to learn about a particular subject or a given field. And so the algorithm basically will read through online databases and websites and starts acquiring the knowledge on a specific topic. And by doing so, it will learn how to connect words related to that topic and see that set of information as a network of terms, you see. And so once the knowledge is acquired, the algorithm is ordered to read texts and disclosures of a given company so that it can help analysts to make investment decisions, especially when it comes to thematic portfolios, because the algorithms are usually applied to learn about ESG topics, impact investment, thematic portfolios as well. And so this is the main purpose, and so that's why they can help make these investment decisions. And so the fourth technique that Mr. Moniz spoke about is deep learning, which is actually is the first one to capture non-linear relationships and data, and it was actually first used to translate text into several different languages. And so basically now this algorithm focuses on grouping words that are semantically similar and usually are close together when presented in text, which is what happens basically when words are related to a specific topic. And so by learning the meaning of those words grouped together, the algorithm is able to learn about that topic, and not only that, and also can be used to read through the statements of data and also data, these other disclosures, for example, of companies. And so that is why it is quite sophisticated and can be used, just as the previous one, to interpret the disclosures of companies, to understand what is the commitment in terms of ESG, in terms of, let's just say, the added value that ESG can provide to their performance, not only in terms of business, but also in terms of their stock. And so this is something that it's really, really groundbreaking in my view. And the last technique presented is, of course, extremely sophisticated, is large language models, which no longer have the limitation which applies to deep learning in terms of the number of words that it can process, which obviously would limit the memory of the algorithm to learn as much as it possibly can. And not only that, another difference of large language models relative to deep learning models is that large language models are able to use the information from the entire World Wide Web and is able to consider probably billions of parameters, even on information that is very recent, and only a few references exist on the internet, and so this is extremely sophisticated, extremely groundbreaking, and also extremely complex to use as well. And finally, Mr. Moniz also discusses a technique which is called retrieval augmented generation, or RAG by its acronym, which is basically intended to improve the quality of large language models by providing external knowledge to complement the model's reasoning capabilities. So basically, when the model is asked a question, it can draw not only on the knowledge that it acquired on its own by scouring the entire World Wide Web, but also the external knowledge which is provided by humans to basically yield some sort of response. And so it builds on from both ends, from basically the information that is out there, but also direct human inputs to be able to learn and basically then make a specific response to a given prompt, which is it's super impressive. And so this is basically used to engaging with companies and, as I said before, hold them accountable on their ESG commitments. And so, as a conclusion, I would say that natural language techniques have evolved, of course, significantly over the past few years, but there is not yet a single approach that can be used for all intents and purposes. Basically, a one-size-fits-all approach, because each one has its own advantages and pitfalls for any given assignment. Sometimes the sophistication of a given approach is too much complex for more basic activities, and so in that case, more basic approaches would be more suitable. So that is why I believe, and of course, and this is also an opinion I formed after I heard Mr. Moniz, there is not really a one-size-fits-all for the use of each of these approaches when it comes to tackle a specific issue or to try to do some sort of research when it comes to companies in terms of their ESG commitments. But now, moving on to the next presentation, the second one, which was delivered by Brian Pisaneschi, who is also a CFA charter holder and who works as a senior investment data scientist for the CFA Institute. And the purpose of Brian's presentation is basically to show how large language models can be fine-tuned for better performance. And first, he gives a background, just a very brief explanation on supervised learning. For the folks who don't know, supervised learning is in which labeled data is used and given to the algorithm for it to learn how to read and interpret information. And also there, on the other hand, unsupervised learning, in which data which is not labeled is given for the algorithm to learn, basically to learn the data. And so, according to Brian, large language models can be considered semi-supervised learning because data does not need to be labeled, on one hand, because the model can mask the data and provides labels to the data itself. And so you can give the unlabeled data to the algorithm, and as you learn the data will be labeled by the algorithm itself, which I think is super interesting, because it really shows that how to what extent the algorithm is able to learn the information that is being given to learn from, and so to be able to learn to an extent in which it can itself label the data. Yeah, this is extremely sophisticated. And however, label data can be used to train the algorithm as well, no problem, basically to provide us the information we want. And this is how the model can be fine-tuned. So even though you don't need to give to the algorithm label data, if you do so, this can be also done to fine-tune the algorithm, and so it will improve its learning and then its knowledge capabilities. And so Brian also discusses the concept of in-context learning, in which examples on the topic in which we want the algorithm to learn from are basically provided to the algorithm itself. And so it can learn to make interpretations by understanding those examples, not only from the data, but you also give specific examples for the algorithm to learn. Brian also discusses the differences between GPT and BERT as generative AI tools, as it mentions that among other differences, GPT is a generative model to create, I would say, large sequences of continued text, while BERT is a generative model better suited to understand a given context and interpret the semantics of the data, such as, for example, sentiment, specific classifications, recognition of memes, for example. For those purposes, BERT is a better tool. And so next up, Brian discusses the reasons why ESG is a suitable field for AI to be used, to be applied. In particular because, first reason, information is fragmented and sometimes it's confusing to interpret. And second one is because it's self-reported and not fully yet regulated. And so it is likely to be biased by the management before it is disclosed. And finally, the third one is because most of it is outdated and is released after a long time after the period under analysis. Sometimes it can go up to a year. So basically 1 year later is when data is disclosed, ESG data is disclosed about the prior period. And so because of this long wait or long lag of time, this is something that makes difficult for us humans to understand. And so it's probably better for an algorithm to learn how to do this and to do it instead of us, and then provide us information or its interpretation of the information. And so Brian also next takes us through a recently published case study, which is available, by the way, for CFA charter holders in the website of the CFA Institute. And in this case study, he takes the experience that he talks about. Basically, all the companies in a specific index are considered, are taken, and then all of their tweets are also taken and filtered for just to consider the ESG related tweets. And so these tweets are then filtered and labeled for different levels of ESG materiality: low, medium, then probably significant or large. So in four different levels of materiality. And so these tweets are then used to train the algorithm, and then 4 portfolios are created, one for each materiality bucket defined for the case. And those portfolios then are rebalanced on a quarterly basis, and the weights of each of the securities in there are set according to a moving average of the number of ESG-related tweets by each company. All right, so more ESG-related tweets, a higher weight is assigned. And then, and this is where it gets a little bit more complicated, to simplify the backtesting process in order to be able to understand, all right, whether the performance of these portfolios is good or is just about average or it's bad. It is used a set of, I believe, 10,000 hypothetical portfolios with random weights of companies, all sorts of random weights. And then, and of course, these companies can potentially be in any index. And from those portfolios, it is selected the portfolio of the 95th percentile of performance. of course. So 95th percentile, 5 of them are have better performance, and 95% of them have lower performance. And this is compared with the 4 portfolios that we mentioned before to determine if there are any excess returns, or they called alpha, generated by an ESG, sort of an ESG factor. And so to give you an overview of the results of the model, it is shown that by labeling the data and fine-tuning the learning experience of the algorithm, a better portfolio performance can be attained for all levels of ESG materiality, all right? Especially in comparison of just using GPT 3.5, which is mostly a text tool, and also in comparison with GPT-4, which it's more sophisticated because it can understand images and voices. And now, if we shift our perspective and compare the performance of the 4 portfolios among themselves and among these, and comparing those with the 10,000 or with the portfolio on the 95th percentile among those 10,000 portfolios, the results are different depending on the type of companies in those 4 portfolios. In the case study, if we assume that these 4 portfolios consist only of large cap companies, all of them performed well within the 95th percentile. So no real outperformance existed. And in fact, the portfolio with the lowest ESG materiality in this experience over several years, I think the experience covered the first decade, most of the first decade of this century, of the 21st century. And so the portfolio with the lowest ESG materiality performed the best of those 4 by a very small margin, which is basically not much material. It's not material. Now, if the 4 portfolios consist only of small cap companies, the portfolio with the highest ESG materiality significantly outperformed the other 3 portfolios and consistently stayed on par with the portfolio on the 95th percentile over the time period under analysis, and sometimes even exceeded it. And so one potential takeaway here is that, which I think is consistent with the real world, is that small companies have a greater ability to innovate and develop new technologies, groundbreaking technologies, as well as making more material disclosures about those new technologies. So I believe that we can all relate to this, because small companies many times are created because someone or its founder or an entrepreneur discovered a specific technology, and so created a company around this technology to make available for a customer base. And so this is something that is more prone to happen with small companies rather than large companies. And so I believe this is consistent with our experience in the real world. I believe overall this is a very insightful case study indeed, and because it basically showcases the potential for thematic portfolios and ESG-based portfolios to outperform the market, of course, under specific conditions, and making, I would say, a wide range of assumptions, as it was in this case study. But yeah, basically that is all from this video. Let me know in the comments below your views and remarks on this very, very interesting topic. I believe this is something that we are going to talk about a lot of times in the future. And so also feel free to like the video, subscribe, and connect with me on LinkedIn in case you have any questions. And so yeah, that's it. I'll see you all on the next one. Bye bye.